Well, now we take the an example for finding average and instantaneous velocity. Suppose that the height of the falling object t second after being dropped from a height of 64 feet is given by this. This is your position function, which is given in feet. Find the average velocity between times t equal to 1, t equal to 2. That means the secant line between these 2 points. Average velocity between again different point and another set of point 1.992, and finally the instantaneous velocity at t equal to 2. See, the average velocity between t equal to 1, t equal to 2, s2 minus s1 by 2 minus 1. These two value I substitute here to get the value of s2 and s1. So I have this, right? And then I subtract, I simplify this, I will get minus 48 feet per second. Velocity is negative. That means it is what you call on the left side of start. The average velocity between the time, again instead of 1 and 2 we have 1.5 and 2. You see, I will just substitute. Now the second point, the first point is 1.5, so here I substitute. Again I substitute these two again here, and I get the answer minus 56 feet per second. Then again I choose another 2 points, that is this time instead of 1.5, 1.9 I choose same point I will take. Then again I subtract, then I will get minus 62.4 feet per second. Please check this. So we have now, let's find out the instantaneous velocity. In the earlier case, we all found, in all the cases, we found the average velocity between the 2 points. Now what I will do, I will find the instantaneous velocity. If the We know that instantaneous velocity is the limit of average velocities. So I will take C s up to h. So the first point I will just put h equal to 0. Then I will take this general one. So 2 plus h, I just substitute because this h is anything here. I mean, I will not take this value here. So I will just substitute this. Then these are the values. And then x is now 2 plus h. So substitute properly in the given position function. Then we have this. Then we subtract. We what you call expand this 4 plus this, and then I open the bracket. Then I have this. Then look at it, 64h. That is what we get here. I mean this is this value, and then minus 16 x square. All other terms are cancelling. Then here and here we have h common. Then I take that common, I subtract, I mean cancel that. Then finally I will get this. So carefully you do all these steps, you will get finally this term and then this term. Now I will find the limit as h tends to 0 for this. So this becomes 0. So minus 16 into 4 is minus 64 feet per second. So look at it. The velocity indicate both speed and direction. So look at it. It is speed and direction, the velocity. In this problem, ST measured the height above the ground. So the negative velocity indicate that the object is moving negative, that is downward direction. The speed of the object at 2 second mark is 64. Look at it. The This is the velocity is minus 64 feet per second. That means velocity is positive, can be positive or negative. Average velocity can be positive and negative, but the speed is always positive. That means we take only the magnitude. We neglect the what you call the sign. So therefore, if you are asked find the speed, so remember here you should neglect this sign. Then you say that the speed at 2 seconds is 64 feet per second. The velocity at 2 seconds is minus 64 feet per second. So what is the velocity? The velocity is rate. Rate means the change. What rate, at what amount it is changing. So velocity is a rate. In general, the average rate of change of function fx between x is equal to a and x is equal to b. This is the average velocity. And for this average velocity, if I'm finding the limit, then it becomes instantaneous rate of change. So note that it all depends upon the units of this average velocity or instantaneous velocity or rate of change or instantaneity of rate of change depends upon units of f divided by units of x. So if t is measured in second and st is measured in feet, then it is feet per second. And one more important thing is that whenever we use the word in velocity, it means I'm talking about the instantaneous velocity. If it is not instantaneous velocity, we will ask it is average velocity. So velocity means instantaneous velocity. Otherwise, if it is average velocity, we will ask find the average velocity. So this is an example that determine whether there is a tangent line to this graph at x is equal to 0. So what I will be doing here is that I am finding the tangent line to this graph at x is equal to 0. That means I find the left hand limit. See, limit of the what you call the same, what you call the the slope of the tangent line, that is the right limit I will find. So limit of the quantity as just tending to 0 plus. So note that this is the absolute value function. So this I substitute, I get this. This value is, if h is positive, this is positive. So see that we have h upon h, the answer is 1. So if h is negative, so this is the right hand limit, and then I will find the left hand limit. Same, quantity I will take, so, and then this modulus h, because h is less than 0, that means this value will be negative. So h cancels, you get -1. Right hand limit 1, left hand limit -1, and they are different. Therefore, the limit does not exist. That means the tangent line does not exist. So that's the particular an example where for a function, if you want to check for any function at particular point, if you want to know whether tangent line exists or not, you need to find right limit, left limit. If they exist and if they are equal, then the limit exists. That means there is a tangent line exists. If not, then tangent line does not exist. So these are the examples where in the first set of questions from 1 to 8, you are given a graph and you are asked to find the equation of the tangent line to this graph at this point. So I will do in the live class some of these examples. In this example, you are asked to find the slope of the secant line at 2 points, 1, 2, 2, 3 for this particular graph. I will do these example. I have already done it earlier now. So you please refer and try to solve these questions. And otherwise, I will be solving in the live class some of the examples from the first set 1 to 8 and 9 to 12. These are the some more examples to find the what you call here the position function is given and you are asked to find the velocity at t equal to say. That means you are asked to find, this is the position function, you are asked to find the velocity at a equal to 1. That means velocity means it's instantaneous velocity. Otherwise, I will mention clearly average velocity. Whenever it is average velocity, 2 points are given. Whenever it is a velocity, at 1 point is given. So you are finding the what you call the velocity at 1 point, one question, another point a equal to 2, not at these 2 points. This is one question, this is another question. In this, we have again, we are given the position function and find the average velocity. See that this is the velocity, instantaneous velocity. Here we are finding the average velocity. See that in question number A, you are given 2 points. So the same example we have already done in this one. So this is the velocity and this is the average velocity. Then here are some examples which is called application. As I told you, application means we are using the concept of mathematics in some other subjects. And here you are given some table is given. Look at it. Estimate, that means find the slope of the tangent line at p equal to 1. The only difference here is that so p is the what you call it is a t now. So you are asked to find the slope of the tangent line at p equal to 1 and slope of the tangent at p equal to 3. So the only difference between the earlier question and this question is that in the earlier question you are given a function. So whatever the value, uh, you substituting in the formula, we are using the function and then finding the value. But here the function is not given, you are given table. So mean for p equal to 0, the value is 0, right? And for p equal to 1, here look at it, the temperature is what you call the F, and what you call P is that the pressure is equal to X here. So this is X and this is Y, or this is F. So when X is equal to 0, Y or F is 0. When X is equal to 1, Y or F is equal to -1. So these values, this table you have to use in finding the slope of the tangent at that particular point. And exactly in the similar way here, this distance is x and this speed is f or y. So here in these two questions, no function is given. You need to use the table to find the value of the function while finding the tangent line. So here also you are asked to find the slope of the tangent line at v equal to 50. That means this value, which is this here. Okay, so I will take up more detail. These one example out of this I will solve, then it will be clear in the live class. In the meanwhile, you try these questions. So what you call understood here is that in short, we understood. We already learned how to find the slope of a secant line, how to find the slope of a tangent line, and also equation of the tangent line, average velocity, and the instantaneous velocity. Please note down these formulas separately. Look at it. Secant line, average velocity is same. The tangent line, instantaneous velocity is the same. Only thing, I will be using different notation or letters to represent. Okay, with this, I complete the video lecture number 1 for week 3. Thank you.